After the granite had formed and it started to set at the 6 miles underground, the outside of it started to form a crust as it set. And what happened then was, as it gradually cooled, it shrank and that made it crack. The inside of it, however, was still molten, and that could be seen by what's called elven dikes. And this section of the rock here is a piece of elven dike, and it is basically exactly the same as granite. The only difference is it's much finer grained because it's set so much quicker. But it's at this stage we first see the evidence that there are also a lot of other minerals around. And where it ran through the granite rock here, we can see the dark staining, where these minerals started to be pushed into the surrounding rock. So this was the first stage at about 260 million years ago, where finally we start to see the tin and also the wolfram appearing. Well, here we have the mountain chain, and here we have the granite that's risen up from depth. It would have melted at around about 35 kilometers down, and it rose to a point 6 miles below surface. And this still had a lot of trapped heat. So what we had is a source to create an engine to actually power the formation of the mineral veins. The water was needed to make these veins, and it came from 3 different sources. So what we have is what's called magmatic water, and that came out of the cooling granite and entered into the surrounding ground. We also had formation water, which is what's already in the mountain chain before the granite appeared. And then finally we have rainwater, called meteoric water, and that comes down into it. And this water starts to form a cycle, and as it drops, it then gets warmed up, causing it to rise and push through. And this bleaches all the surrounding rock around the granite. And this bleaching process pulls in all of the minerals that are in it, all your tin and your copper, and it starts to concentrate it. And as it rises up through here, it forms fractures in the rock. These run through the country rock, they also end up rising up through the granite itself, and these fractures are what are going to form the mineral veins. As the rock's still cooling, the joints start opening up again, and as they open up, that lowers the pressure and these minerals can start depositing on the walls either side of this. The first ones to form were the wolframite, which is where we get tungsten from. Further out, where it's a little bit cooler, we get the tin, and then further out again we find the copper. And the water would have then come out to surface, and it would have made geysers with great big fountains of water coming to surface and then running back down with the meteoric water back into the cycle. And this would have carried on for a good 65 million years, gradually making the mineral veins richer and richer until there are points where they're actually worth mining. Well, we mentioned earlier that these mineral veins started to form 6 miles underground, but that's far too deep to mine. So in the 260 million years since then, all of that has been eroded off. Now, several processes helped in this. One is that 260 million years ago, we were actually very close to the equator, and that meant that we had tropical weather, and that caused deep erosion, and that kaolinized the granite, and that's a process whereby the feldspar actually gets broken down. Here we have normal granite, which even though it's been exposed to the weather, is actually incredibly hard. But the process of kaolinization makes rock which is really soft. And what happens is, in the tropical conditions, all the water gets in and starts to eat away at the feldspar in it. The other way this can happen is from steam, and that's when you have later mineral veins actually breaking down the granite. But it's from this that we get our china clay, which is used for making china, used in paper, and even used in things like toothpaste. And this was left behind to make another thing that could be mined in the southwest.